Okay. Hello. Welcome to Physics Live once again. Myself Ankan Bhattacharya, MSc student, VNIT Nagpur. So here we will discuss about something which is related to LVDT. At first we will discuss what is LVDT, then we will discuss the construction and working, and afterwards we will see what we can do. So what is LVDT? LVDT means linear variable differential transformer, which is a common type of electrochemical transducer or sensor which acts as a transducer which can convert the mechanical energy to the electrical signal. Okay, it consists of mainly three parts: one primary coil and two secondary coils along with a soft iron core inside it. So let us see the construction in detail. So here is the construction of LVDT. As I have told you, it consists of primary coil, which I have shown in the red color, which is related or which is connected with the AC source, and the two secondary coils which are shown in the yellow color, and the left hand side coil as I have designated as secondary coil 1 and the right hand side coil as I have designated as secondary coil 2 are connected in series opposition connection, so that what does it result, we will see. And there is a soft iron core between it which induces a magnetic flux. Okay, an uniform magnetic flux is produced due to this, which is equally shared, or the induced EMF produced by the application of the change in the magnetic flux according to the Faraday's law is equal in magnitude but opposite in polarity as developed in the two secondary coils. Let me explain you. Okay, why these are opposite at the two secondary coils? Because it is connected in series opposition connection. If I have some laser source, I think yes. So there is the magnetic flux which I have indicated as the blue dotted line, and same thing in lower level also. So it is equally induces equal EMF at the two secondary coils but opposite in polarity, so that the resultant differential output voltage E0 is equal E1 minus E2. Now as because the two EMF are equal, the resultant differential output becomes 0. So this is the case 1 when the core is present at the central position of the primary coil. Now we will see, if we change the position of the core, then how can it affect the LVDT. So this was the case 1. Now we will discuss if the core is shifted slightly towards the secondary coil 2. What does it result? It influences a greater magnetic flux linked with the secondary coil 2, which induces itself a greater EMF as compared to the secondary coil 1, which I have designated as uh, large font size E2 and small font size E1 to designate the relative magnitude. And the differential output in this case E1 minus E2, as E2 is greater in magnitude, it results into negative. Okay, so let us proceed. Let us see, if the core is near the secondary coil 1, what does it result? As a similar manner, if the if the core is near to the secondary coil 1, then it also induces some magnetic flux which is greater in the secondary coil 1 as compared to the secondary coil 2, which induces greater EMF at that side as compared to the other. So I have designated here the bold E1, which is greater font size, and small E2, which is uh, used to designate the smaller value, so that the differential output voltage in this case E1 minus E2, E1 is greater, so it becomes positive. Okay, so what conclusion can be drawn from this? We can say that the EMF induced at the secondary coil is proportional to the displacement of the movable iron core. How the core moves, it affects the induced EMF at the secondary coils, as we have seen in the demonstration. So let us verify this thing by a simple experiment with some experimental kit. Here I have shown the experimental kit which is collected from the Google. So you can use this in your laboratory and get out the result as I have obtained here. So what is our aim? Our aim is to study the input and output characteristics of the linear variable differential transformer. So why it is called linear, we will see in this slide, or afterwards the results coming out from this experiment we will explain why it is known as linear. Why it is variable, as we have uh, already shown that by variation of the what we can say, the variation of the core or the displacement of the core results into the variation in the induced EMF. And why it is differential, as because the two secondary coils are connected in series opposition, it induces EMF which are opposite in sign, so that the resultant output voltage is differential, that is E1 minus E2, as we have shown earlier in the slides. So now what we will do in the experiment, at first we will switch on the trainer kit, then make the micrometer screw which is attached here at the screw gauge, make the micrometer screw at the 10 millimeter position, where the display, here it is the display, where the display shows 0 of the circular uh, 0 reading. Okay, now what we can do, we will rotate the thimble at the screw gauge, so that by rotating it, if we rotate it clockwise, then we will go from 10 to 9.9, 9, 9.5, 9, 8.5, etc, etc, as we will go in this, and we will change, we will see the change in the uh, induced EMF in the display. Okay, so at first we will make the position where the display reading is 0. Here the 10 millimeter position is this. Now we will uh, go either to clockwise direction. If we go the clockwise direction, then it, the core will go more and more to the secondary coil, near to the secondary coil, and by rotating like this manner, it will reach at the highest point of the secondary coil 1, which shows that highest voltage obtained at the secondary coil 1, and that of the lowest voltage is obtained at the secondary coil 2, as I have demonstrated by the animation in the earlier slide. These things will happen in your experiment also, and you can verify the theory by the help of this. But it should keep in mind that the secondary coil 2 has the lowest induced EMF, although it has contain lowest induced EMF, but it is not the 0 actually. Okay, now what can we do? If we are going with the clockwise direction, then now we will go to the anti-clockwise direction from the 10 millimeter position. That is, if we can increase 10 to 11, 12, 13, etc, up to the maximum limit as present in the screw gauge. So by rotating the same thimble in anti-clockwise direction, we will come to the extreme end at the secondary coil 2, where it induces highest EMF at the secondary coil 2 and the lowest EMF at the secondary coil 1, but the lowest value is not 0. Okay, let us see the observation table coming out by approaching with this procedure. So this is our observation table. As you can see clearly, at the 10 millimeter position I have obtained the display reading 0, whereas if we rotate it clockwise direction, then it approaches to 9, 8, 7, and you can see the readings will increase in the positive direction. Means the induced EMF is increasing at the secondary coil 1, whereas if we go to the anti-clockwise direction, if we rotate the thimble to the anti-clockwise direction and go beyond 10, 11, 12, 13, 14, it will simply gives negative. What does it result? It results into the fact that the induced EMF at the secondary coil 2 here now increases. Okay, and the induced EMF at secondary coil 2 is decreasing, and at the extreme point the induced EMF due to the secondary coil 2 is maximum and the secondary coil 1 is the lowest, but not 0. So if we plot these observations on a graph paper, then what we can get? You can get a linear curve like this. Okay, that's why it is known as linear variable differential transformer. Okay, so what are the application? We have studied LVDT. Its working principle is construction, and we can check the linear behavior as well as the input output characteristics of the LVDT. But where we can use this LVDT? So the first point is that LVDT can be used as the secondary transducer or sensor for measuring force, pressure and weight, etc. And the second point, which is very much important and very much useful nowadays, LVDT can be used as a robotic cleaner. What does it mean? A hydraulic oil compatible LVDT is used to continuously monitor the fluid level as part of the leakage detection system. If there is some leakage, it can completely recognize and acts like a sensor, so that it can be used as a robotic cleaner or hydraulic oil compatible LVDT. Next thing is that to provide the displacement feedback for the hydraulic system, LVDT can be used. And the other application is to measure the distance between approaching metals during friction welding. LVDT can be used as it can recognize the smallest displacement by the production of the electrical signal. Okay, so now we will discuss some advantages of it. It provides a good accuracy. Even a small amount of displacement can be recognized by it. So it has a good sensitivity also. In our experiment, we have found the sensitivity is nearly about 9.4 millivolt per millimeter. Okay, and the important thing is that it has high output and resolution, so it does not require any amplifier circuit to amplify the output to show in the instruments. It can already produce the high output, and the resolution is very high. The next point is there is relatively zero mechanical friction, and there is low hysteresis loss. Why? As because we are using the soft iron, which has the low hysteresis loop, as the area covered by the, what we can say, hysteresis curve is very small. Like the advantages, it contains also some disadvantages. What are these disadvantages or limitation? It is sensitive even to the stray magnetic field. If there is some stray magnetic field outside your instrument, your instrument cannot work properly and it gives some erroneous result. Next thing is that large displacement sometimes is required to produce appreciable output. It happens sometime that some large displacement is required to produce an appreciable output. Okay, and the next thing is that it can be affected by the temperature and pressure, so that your instrument should be kept in a very uh, safe environment, not affecting by the temperature and pressure, so that you can get uh, accurate result. So thank you very much for listening all these things and for being with me. Um, I hope you have enjoyed the lecture and something about LVDT I am able to explain about it. So thank you very much.